Good morning, everybody. My name is Carlos Sattler. I'm taking this class remotely, so that's why I cannot be with you this morning. My presentation will be on neural nets in NLP competitions, two recent examples from Kaggle. The agenda for my presentation is the following. I'll talk about Kaggle initially for those who haven't heard of it. I will go over the first competition, talk about lessons learned in that competition, go over a second competition, also cover what I learned from that one, and share with you my final thoughts at the end. Kaggle is an internet platform for data science competitions. It's a Google company since March 2017. It started as a very small company, and it grew with time to the point where Google bought it last year. It has a very large community of practitioners. It's a great place to learn. People really share their knowledge there. Very collaborative environment, and also home for many very intense competitions. Here's the site for Kaggle. I'll close these windows here. You will see there are 17 active competitions. One of them offers $100,000 in prizes. The first competition I want to share with you is the Mercari Prize Suggestion Challenge, sponsored by Kaggle with Mercari. Let's see what Mercari does. It is an online retailer. Let's explore one of their items here. Armani jeans, sold for $25. Here you will see some of the features associated with this sale here, with this item: condition, size, shipping, brand. There are 3 category fields and a description of the item. The competition consisted in predicting the price of the item from those fields I just shared with you. The prizes were up to $100,000. I think it was $60,000 for winner, 30 and 10 for second and first place respectively. I finished 11th percentile in that competition. Here's the competition site. An example of 2 items: Vince long sleeve turtleneck pullover sweater. Here's another item, and you would have to predict the price of this item based on these descriptions and these other features here that are also part of the data set. A little more about the data set: name, item, condition, category. So I'm showing you this, and at the end here you will see that the price is a long tail distribution, so we definitely wanted to put this in a log scale. So the lessons learned, the lessons learned in this competition mostly were 3 for me. Simple works. So you will see that the winners, and here I am relating to you what the winners did and what I learned from them and what everybody learned from them. These are the guys that won here, giving them credit. And my discussion is based on what they shared about their winning solution, including the code. They share the code. I'll go over the code in a minute. First lesson learned is that simple works. So these guys won with sparse MLP models. Actually, they had one model that they settled with, and they used a bag of words, therefore a sparse vector, and that was what really did it. They used 3 data sets. That's the second lesson that I learned. You can get better results with more data sets. I will talk a lot about that. And they combine data sets, and they use an ensemble. That's yet the third lesson that I learned very important lesson. I will share more details about each one of these things. The winner code is amazingly small. Okay, so you will see here that this is how long it is. It's, I think, 57 lines, maybe a little more. Yeah, 75 lines of code. Okay, this is an approximation of the winner code, but it captures the essence of it. You will see here the architecture of the network. You have 1, 2, 3, 4 dense layers. These are keras layers. So it's a 4 MLP, 4 deep network. Very straightforward. And we'll see why it was so effective for this problem in a minute. If you want to hear the details about the solution, you can go and check the winners post here. So they also created a presentation. I put the link here to the presentation. They shared their solution, and they summarized their journey, if you will, in this presentation. And I pulled some of the figures from the presentation, and I'm sharing them with you here. So this graph shows the root mean squared log error evolution during the competition. This was the evaluation metric for the competition. Notice that they started with a recurrent neural net. Then they switched to convolution CNN, 1G CNN with 3 layers, and then they switched over to the sparse MLP at some point. After that, they started to get better. They went from gold, which is the 10% top scores, to second place using the sparse MLP, which is, bag of words with MLP. And at some point they merged their solutions, so we had the winner team were 2 guys, and they at some point they merged their solutions. And you will notice that after they got past second place, they started to improve only by using more and better data sets. So that's really interesting here, that they would use multiple data sets to get better results. So let's take a look at the data sets they used. They used 3 data sets, and in some cases they combined them to fit into their models combinations of data sets. Actually, they only had 1 model, like I said before, and they just used the same model over 3 data sets and combinations of the data sets. The first one is just, they created stems for each of the words, and they used a bag of words of 1-2 grams with and without TF-IDF, and they did 1 hot encoding of categorical columns. The second data set was a bag of characters, 3 grams, and then and this is all done with scikit-learn and the vectorizers in scikit-learn. Those are the ones that are used normally or at least the popular ones to use if you're doing a bag of words in these competitions. Very effective, useful tools available with scikit-learn. And they created a third one, joining name, brand, name, description into a single field. Okay. This is again a copy copied from their presentation. The reason why they use multiple data sets, it goes back to what in the book is described or discussed in page 192 of our book. I'm referring to the Deep Learning Network, to the Deep Learning book by Ian Godfellow. So I'm going to read here real quick what's on page 192 and 193. The universal approximation theorem means that regardless of what function we are trying to learn, we know that a large MLP will be able to represent this function. We're not guaranteed, however, that the training algorithm will be able to learn that function. So what they are trying to do by using multiple data sets and ensembles is deal with that limitation, right? So they are using multiple data sets to see if they get a better shot at learning the function. And the ensembles, they are very helpful also because not only they find averages for the mean loss from all the runs over all the data sets, but also if you find a local mean, then you can average and all your results, and hopefully you will get a better estimate for the global mean, right? So that's what I'm trying to represent with this slide here. Another good illustration of the power of ensembles was provided by this user here, Tilly, in this post. I copied the main point that he's trying to make in that post. So imagine you have the ground truth here represented as a string of bits, and you have a weak learner that's good at predicting ones with 70% accuracy, and you have another weak learner that's good at predicting zeros with 70% accuracy, and then you have an overall weak learner that only has a 60% accuracy and it's not good at predicting anything. Now, if you do an ensemble that averages that performs a vote average of weak learners, all these three weak learners, you get 100% accuracy. It's a very illustrative example about the power of ensembles. The second competition was a text classification competition, and it was sponsored by Kaggle in conjunction with Jigsaw. Jigsaw is another Google company, and they have a project called Conversation AI. So let's take a quick look here. Few things poison conversations online more than abusive language, threats, and harassment. We are studying how companies can learn to understand the nuances of context of abusive language at scale. So one of the things that this company is doing is they are creating an API that folks that moderate discussion boards can invoke and help moderate discussions online. So Jigsaw got together with Kaggle and they created this competition. It's a toxic comment challenge, classification challenge. I have it here showing to you the featured competition page. It offered 35,000 in prizes. Okay, and going back to my slides, what this competition did was it would the data set was pretty simple, just one comment field, sometimes a very large comment, and you would have to predict if that comment was considered toxic, if it was considered a threat, etc. It's a text classification problem. I finished 55th percentile on that one. I didn't have time. This is a more recent competition. Our class was already full steam, so didn't have much time for that one. I will show you the data set real quick. This is a script created by this user here, Jagan, that I'm going to share with you. One thing that I want to call your attention, this is attention to, it's a very challenging competition because the classes were very imbalanced. So you will see here the clean comments are very, very many compared to the percentage of the ones that were considered toxic, severe toxic. You see threats, very few threats. So the classes are very imbalanced, as you probably know. It's very challenging to deal with imbalanced classes in classification problems. And the evaluation metric for this competition was ROC, area under the curve. So going back to my slides, I wanted to share with you a solution, one of my solutions. It didn't perform that great, but I thought it was interesting to share with you because I implemented something that we learned in the paper, Natural Language Processing Almost from Scratch. I used Spacy to extract NLP features, So you may have seen this page from Dr. Chavan's notes. There is a here's a snippet of the code that allows us to extract different NLP features using spaCy, right, from all the tokens in documents. So you will see that you can use this to extract lemmas, part of speech tags, dependencies. And what I did in my solution was I extracted all the features from the text and I created a tensor to feed into a convolutional network, and it concatenates the part of speech tag, the dependencies. I also created a vector representation of the words that are that were uppercase, because if it's a toxic comment, a lot of times people write in uppercase letters, right? And also lemmas, and I concatenate all of that, and I use that as input to a convolutional network. So I thought I'd share this with you. Like I said, this solution wasn't very competitive, but still, you know, it got me a good result, but not really that competitive. The lessons learned from this competition are more of the same. They used, in this case, they used recurrent neural nets, GRUs, most specifically, were very successful in this competition. They used a number of different pre-trained word embeddings. So they used GLOVE, they used fast text, they used a bunch of pre-trained, many of them I had not heard about, but if you're interested, you can go and check the discussion board for this competition. You will see there are so many pre-trained word embeddings, and they are trained in Wikipedia and a web crawler. So they created a bunch of versions, actually, of the data set by using different pre-trained word embeddings. So again, we're dealing with a solution. We are here witnessing a solution that had many data sets. And what was really interesting is that they also used data set augmentation. Somebody had an idea to translate all these comments into French, German, and Spanish, and then back into English. And they augmented the data set, you know, a lot by doing that. The winner solution and all the very competitive solutions, the ones that ended at the top, most of them did that. Again, ensemble. They create all these data sets. In this case, they created many models. They run the many models over different combinations of the data sets, and they average the solution, average the results. In this case, they did some other machine learning tricks that do not apply to our class so much, so I'm not going to go over them, but you can explore. They have to do with stacking, which is something I had not heard about, and very interesting advanced tricks that they used to win. These are the winners. I'm trying to give them credit here, and details of the solution can be found in this link. My final thoughts, neural nets rule. That's evident. There were other solutions using different algorithms from scikit-learn and boosting trees and things that are not neural net solutions, but in both cases, the people at the top, they all use neural nets, right, for these NLP problems. More data sets, better results. That also was very clear. Very important lesson learned. If you're dealing with a machine learning problem and you want to improve your results at your work or any of these competitions, make sure to create several versions of your data set, and you'll probably get better results if you're not just adding noise, right? Like, for example, our NLP features in some cases, like in my solution, that solution I shared with you, was I adding noise by adding, for example, part of speech tagging for this problem, right? And ensembles, right, that always yield better results. One thing that I thought was noteworthy was the fact that not a lot of linguistic features were explored in these solutions. Of course, if in the second competition, because they used pre-trained word embeddings, you were dealing with semantic information, of course, right? Because as we learned, the vectorized representations of the words, they capture meaning. The similar words, they have a small cosine distance between them. So in a way, you are exploring linguistic features, but still we learned about so many other linguistic features and I didn't see them being used. So I wonder, would they yield better results? Did the competitors explore that? I certainly didn't have the time to go deep into that. The final thought is, well, actually one before last, no free lunch. You will see it very clearly in these two competitions, and if you look more in depth into all the other competitions, you will see there's no silver bullet. There are certain things that you can do, like more data sets, use ensemble, and so on, but the algorithm itself that you're going to use that will give you good competitive results in these competitions, it's always going to be slightly different, if not a lot different. In this case, you had a very straightforward NLP single model working against many data sets in the first competition, and in the second competition you had different recurrent networks, and still many data sets, but you had many recurrent networks. And finally, this is the final thought, team up. This is a lot of work, and the more people that you can bring to your team, the better it is, because it's a lot of work, a lot of coding, and you need to generate ideas, so you are much better solving these problems if you team up. If you have any questions, email me. This is my email, and please CC Dr. Chavar for all questions. Thank you very much for your time. I hope you guys enjoyed this presentation, and have a wonderful day.